In this lecture, I want to talk about the sample size needed to estimate the population mean within a given margin of error. So what do I mean by that? So we know for confidence intervals, one factor that determines the margin of error is the sample size, right? So what I mean by that is obviously the larger the sample size, the smaller the margin of error. Okay, so what we want to do in this lecture, and there'll be another video that talks about sample size needed for a population proportion. What I want to talk about is if you set the margin of error. So you start by you set the margin of error. Okay, so the problems will be like something like I want to be within 5, or I want to be within 3%, something like that. I want to be within 5 of the real population mean, or I want to be within 3% of the real population proportion. So you're setting the margin of error. If you set the margin of error, you have to figure out next then, well, I'm going to need a large enough sample size to meet that margin of error. So what will that sample size be? Okay. And so what I'm going to show you in this lecture and then a follow-up one is how you find that sample size. All right, so this will be the formula for determining the sample size n for a population mean. Okay, so the sample size required to estimate the population mean mu within a level of confidence, 1 minus alpha times 100%, so it'll be something like a 95% confidence interval or a 99, with the specified margin of error E. Okay, so E, you're going to be given the margin of error is just given by this formula. The sample size n is equal to z of alpha divided by 2. Okay, that's the z critical value. I'm going to give you a nice easy chart for this. Times S, so S, you'll either be given the sample standard deviation, but really you'll be given the sigma, the population standard deviation. Divided by the error, so the given margin of error. You do that calculation, this times this divided by E, and then you just square it, okay? And then that's going to give you some number, okay? And this is where N is rounded up to the nearest whole number. So you're always going to round up for these type of problems. No matter what for these sample size numbers. All right, so what I want to do is I just want to walk you through 2 quick examples of this. All right, so we'll go back to the pennies example. All right, if you remember, we talked about the weights of pennies minted after 1982 in a bunch of lectures. So how large a sample would be required to estimate the mean weight of a penny manufactured after 1982 within 0.005 grams? Okay, so this right here is the margin of error. So you're given E, okay, it's 0.005. This right here, you're saying with 99% confidence. So the Z critical value, Z of alpha divided by 2 is a 99% critical value, which I've given you on the next slide here. So you look 90 whenever you have a 99% confidence level, Z critical value is 2.575. And then you're given sigma, okay? You're given the standard deviation. So look, E, Z of alpha divided by 2, and sigma. Here it's S or sigma. Look, you're given all 3. So this is just a plug into the calculator and solve problem. So again, as I said, you're given the Z critical value, you're given the standard deviation, you're given the error that you wanted. I'll do this in my calculator for you, just so that you can see. So in parentheses, you're going to do the z critical value, which is 2.575 times the standard deviation, 0.02, divided by the error, 0.005, close the parentheses, and then square it. You get 106.09, which is what you see right here in the lecture. Okay, so rounding this up, the sample size you would need a sample size of at least 107 pennies, so that that sample mean that you collect, okay, from 107 pennies will be within 0.005 grams of the actual weight. All right, let's do another one real quick. Suppose an economist wishes to estimate the mean age mu of all people in the civilian labor force. Okay, determine the sample size needed to be in order to be 95% confident that mu is within 0.5 years of the point estimate. Okay, so I want a 95% confidence. So that means my z of alpha divided by 2, my z critical value is 1.960. Just looking at that chart. The error, because I want to be within 0.5 years, so you're given the margin of error. And then it says assume the population standard deviation is 12.1 years, so you're given sigma. So then you just need to follow that formula, right? So n is equal to z of alpha divided by 2 times the standard deviation over the error squared. So this is just 1.960 times 12.1 all over 0.5 squared. All right, let's grab our trusty calculator. So then in parentheses, right? 1.960 times standard deviation, which is 12.1, divided by 0.5, close the parentheses, and then I want to square. So you get 2249.7. So you would need to sample 2,250 when you round this up, because you always round it up. Okay, and please note, the sample size is so large because the margin of error here is really small. So if you want to be that close, okay, to the actual mean, you're going to have to sample 2,250 people. Wow. So let me just note that always round up. All right. So I'll follow this lecture up with one about a sample size needed for a population proportion